Galileo Galilei, born on February 15, 1564 in Pisa, Italy, stands as one of the most influential figures in the history of science. His groundbreaking contributions to physics, astronomy, and the scientific method laid the groundwork for modern science. Galileo's insatiable curiosity about the natural world and his willingness to challenge established doctrines led to significant advancements, most notably his improvements to the telescope and his advocacy for the heliocentric model of the solar system. Today we explore Galileo's life, his scientific achievements, and the conflicts he faced, culminating in his eventual punishment by the Roman Catholic Church. Galileo was born into a musical family. His father, Vincenzo Galilei, was a lute player and music theorist. Despite his musical background, Galileo showed an early interest in mathematics and mechanics. He enrolled at the University of Pisa in 1581 to study medicine, a subject chosen by his father. However, Galileo's true passion lay in mathematics and physics, and he soon abandoned his medical studies to pursue these interests. In 1589, Galileo secured a position as a mathematics professor at the University of Pisa. His time at Pisa was marked by his revolutionary approach to physics, particularly his studies on motion and the dynamics of falling bodies. His famous experiment, often depicted as dropping two spheres of different masses from the Leaning Tower of Pisa, demonstrated that the time it takes for objects to fall is independent of their mass, contradicting the Aristotelian belief that heavier objects fall faster. While historical accuracy of this experiment is debated, it symbolizes Galileo's empirical approach to scientific inquiry. Galileo's curiosity about the natural world drove him to explore various phenomena. His investigations into the motion of pendulums led to his discovery of the isochronism of pendulums, a principle later utilized in the development of accurate timekeeping devices. In 1602, he observed that the period of a pendulum is independent of its amplitude, a finding that challenged prevailing notions of motion. His exploration of projectile motion further contributed to the understanding of mechanics. Galileo demonstrated that projectiles follow a parabolic trajectory, a result of the combination of uniform horizontal motion and uniformly accelerated vertical motion. This insight laid the foundation for the study of kinematics and dynamics, influencing future scientists like Isaac Newton. One of Galileo's most significant contributions to science and technology was his improvement of the telescope. Although he did not invent the telescope, Galileo's modifications in 1609 allowed him to create a device capable of magnifying objects up to 20 times. This breakthrough enabled him to make unprecedented astronomical observations. With his improved telescope, Galileo made several groundbreaking discoveries. In 1610, he observed the four largest moons of Jupiter, now known as the Galilean moons, Io, Europa, Ganymede, and Callisto. This discovery challenged the geocentric model, which posited that all celestial bodies revolved around the Earth. Galileo's observations provided evidence that not everything in the cosmos orbited the Earth, supporting the Copernican heliocentric model. Galileo also observed the phases of Venus, noting that Venus exhibited a full set of phases similar to the Moon. This observation could only be explained if Venus orbited the Sun, further supporting the heliocentric model. Additionally, he studied the rough and uneven surface of the Moon, debunking the Aristotelian belief that celestial bodies were perfect and unchanging. Galileo's contributions extended beyond astronomy. He developed a device known as the Galilean thermometer in 1593, an early version of the modern thermometer. This device relied on the expansion and contraction of air within a tube to measure temperature changes. Although it was not as accurate as later thermometers, it represented an important step in the development of thermometric technology. Galileo's work at the University of Pisa included his famous experiment on the motion of falling bodies. While the iconic image of Galileo dropping spheres from the Leaning Tower of Pisa may be apocryphal, his investigations into the principle of inertia were revolutionary. He proposed that an object in motion will remain in motion unless acted upon by an external force, a concept that contradicted the Aristotelian view that continuous force was required to maintain motion. Galileo's experiments with inclined planes provided empirical support for his ideas about inertia and motion. By rolling balls down inclined planes and measuring their speed and acceleration, he demonstrated that the acceleration of a falling object is constant and independent of its mass. This concept of uniform acceleration became a cornerstone of classical mechanics. Galileo's telescopic observations of celestial bodies led him to embrace the heliocentric model proposed by Nicolaus Copernicus. In 1543, Copernicus had suggested that the Earth and other planets orbit the Sun, challenging the long-standing geocentric model endorsed by the Catholic Church and Aristotelian philosophy. Galileo's discoveries, including the moons of Jupiter and the phases of Venus, provided compelling evidence for the heliocentric theory. In 1610, Galileo published Sidereus Nuncius, the Starry Messenger, a short work detailing his astronomical observations. This publication brought Galileo both acclaim and controversy. He became a prominent advocate for the Copernican system, engaging in debates and correspondence with other scholars. His support for heliocentrism, however, brought him into conflict with the Catholic Church. The Catholic Church, adhering to the geocentric model, viewed the heliocentric theory as heretical. In 1616, the Church formally declared the Copernican system to be contrary to Scripture. Galileo was warned by the Inquisition to abandon his support for heliocentrism and to refrain from teaching or writing about it. Despite the warning, Galileo continued to advocate for the heliocentric model. In 1632, he published Dialogue Concerning the Two Chief World Systems, a work that presented arguments for both the geocentric and heliocentric models. Although Galileo attempted to present the heliocentric view as a hypothetical discussion, the book was widely interpreted as supporting heliocentrism and mocking the geocentric model. The publication of the dialogue led to Galileo's trial by the Roman Inquisition in 1633. He was found guilty of heresy for advocating the Copernican system and was forced to recant his views. Galileo was sentenced to house arrest for the remainder of his life, during which time he continued to work on his scientific writings, including 2 new sciences, which summarized his work on kinematics and the strength of materials. Galileo spent his final years under house arrest in his villa in Arcetri, near Florence. Despite his confinement, he remained intellectually active, continuing his scientific investigations and correspondence with other scholars. He became blind in 1638, but dictated his remaining works to his pupils. Galileo died on January 8, 1642, in Arcetri. His contributions to science, however, endured long after his death. His advocacy for the heliocentric model laid the foundation for the acceptance of Copernican theory, and his empirical approach to scientific inquiry influenced future generations of scientists. Galileo's work on motion and mechanics directly contributed to the development of classical mechanics and the formulation of Newton's laws of motion. In the centuries following his death, Galileo's contributions to science were increasingly recognized and celebrated. In 1992, the Catholic Church formally acknowledged the validity of the heliocentric model and expressed regret for the way Galileo was treated. Today, Galileo is remembered as a pioneering figure who challenged established beliefs and expanded humanity's understanding of the cosmos and the laws of nature.